This is the EdExcel A-Level Maths Paper 1 from the June 2024 series. Question number 1. g of x is equal to 3x cubed subtract 20x squared plus k plus 17x plus k, where k is a constant. Given that x subtract 3 is a factor of g of x, find the value of k. Well, if x subtract 3 is a factor of g of x, that means then g of 3 is equal to 0. Let's replace the x with 3 and set g of 3 equal to 0. That means we would have 3 multiplied by 3 cubed subtract 20 multiplied by 3 squared plus k plus 17 multiplied by 3 plus k equaling 0. 3 multiplied by 3 cubed, that's 81. Negative 20 multiplied by 3 squared, that's negative 180. 3 multiplied by k is 3k. 17 multiplied by 3, that's 51. We add on k, and this is equal to 0. And if we simplify, 3k plus k, that's 4k. 81 subtract 180 plus 51, that's negative 48. So we have 4k subtract 48 equals 0. And therefore, solving for k, you will find k to equal 12. And if we replace the k with 12, that means g of x is equal to 3x cubed subtract 20x squared plus 12 plus 17x plus 12. Meaning g of x is equal to 3x cubed subtract 20x squared plus 29x plus 12. Question number 2, part A. Find in ascending powers of x the first 4 terms of the binomial expansion of 1 subtract 9x to the power of 1/2, giving each term in simplest form. In this question, we would have to use the formula highlighted here. So, for part A, 1 subtract 9x to the power of 1/2, that will be given by, well, for the first term, we would have 1. For the second term, we would have 1/2 multiplied by negative 9x over 1 factorial. For the third term, we would have 1/2 multiplied by 1/2 subtract 1 multiplied by negative 9x squared over 2 factorial. For the fourth term, we would have 1/2 multiplied by 1/2 subtract 1 multiplied by 1/2 subtract 2 multiplied by negative 9x cubed over 3 factorial, and then we add on the higher order terms. So we've got 1, then 1/2 multiplied by negative 9x over 1 factorial, that's negative 9x over 2. For the next term, we have 1/2 multiplied by 1/2 subtract 1 multiplied by negative 9 squared over 2 factorial. So for the third term, we have negative 81x squared over 8. And for the fourth term, we have 1/2 multiplied by 1/2 subtract 1 multiplied by 1/2 subtract 2 multiplied by -9 cubed over 3 factorial. So for the first term, we have -729 x cubed over 16. And then we add on the higher order terms. Part B. Give a reason why x equals -2/9 should not be used in the expansion to find an approximation to root 3. If we think about the 1 subtract -9x to the 1/2, the expansion of this will only be valid for the mod of x being less than 1/9. Now, x equals -2/9 is outside of this range, and therefore should not be used. So we will not use x equals -2/9 to help us find an approximation for root 3. Question number 3. f of x is equal to x plus the tan of 1/2 x, where x is in between pi and 3 pi over 2. Given that the equation f of x equals 0 has a single root alpha, part A, show that alpha lies in the interval 3.6 to 3.7. For part A, let's begin by finding f of 3.6. f of 3.6 is equal to 3.6 plus the tan of 1/2 times 3.6. So let's work this out. 3.6 plus the tan of 1/2 times 3.6, that's equal to -0.686, etc. And this is less than 0. Let's now find f of 3.7. f of 3.7, that's equal to 3.7 plus the tan of 1/2 times by 3.7. So we have 3.7 plus the tan of 1/2 times 3.7, that's equal to 0.211, etc. And this is greater than 0. And therefore, as we have a change of sign, we have negative to positive, and the function is continuous in the interval, we can therefore conclude that there is a root in the interval 3.6 to 3.7. Part B. Find f dash of x. For part B, we know already f of x is equal to x plus tan of 1/2 x, and therefore, to find f dash of x, we would have to differentiate this function. Differentiating x, we end up with 1. Now, to differentiate tan of 1/2 x, well, in the formula book, the differential of tan kx is k sec squared kx, meaning tan of 1/2 x differentiated is 1/2 multiplied by sec squared of 1/2 x. Part C, using 3.7 as a first approximation for alpha, apply the Newton-Raphson method once to obtain a second approximation for alpha. Give your answer to 3 decimal places. Highlighted in yellow is the formula for the Newton-Raphson iteration for solving f of x equals 0. And that is shown here. Now we know x0 is equal to 3.7. That's our first approximation. So for our next approximation, x1, that's equal to x0 subtract f of x0 over f dash of x0. We know that x0 is 3.7, so x1 will equal 3.7 subtract f of 3.7 over f dash of 3.7. So we have 3.7 subtract 3.7 plus tan of a half times 3.7 over 1 plus 1 half sec squared of 1 half times 3.7. So we have 3.7 subtract 3.7 plus the tan of 1 half times 3.7 over 1 plus 1 half times by 1 over the cosine of 1 half times 3.7, because we've got x, and then we square this. So what we end up with is 3.672051617. So to 3 decimal places, we would have 3.672. Question number 4. Given that y equals x squared, use differentiation from first principles to show that dy over dx equals 2x. Shown highlighted in yellow is the formula that we would use for differentiation by first principles. That is, f dash of x is equal to the limit as h tends towards 0 of f of x plus h subtract f of x over h. So, f of x plus h, that's equal to x plus h all squared, which simplifies to x squared plus 2xh plus h squared. And f of x, that's equal to x squared. Therefore, f dash of x, that's equal to the limit as h tends towards 0 of f of x plus h subtract f of x over h. So we have the limit as h tends towards 0 of f of x plus h, which we have just found to be x squared plus 2xh plus h squared, and we subtract from this f of x, which we have found to be x squared. And then we divide all of this by h. So we have the limit as h tends towards 0 of, well here, x squared subtract x squared gives us 0x squared, and then we've got 2xh plus h squared over h. Here the h is simplified to 1, and here h squared over h is just h, so we have the limit as h tends towards 0 of 2x plus h. Now, as h tends towards 0, 2x plus h will tend towards 2x, so f dash of x is equal to 2x. Question number 5. The function f is defined by f of x equals 2x subtract 3 over x squared plus 4, where x is a real number. Part A, show that f dash of x equals ax squared plus bx plus c over x squared plus 4 squared, where a, b and c are constants to be found. Now here, the function f is a function that has terms in the numerator and terms in the denominator. Therefore, to differentiate f, we would have to use the quotient rule. So, for part A, the quotient rule is given by f dash of x equals v u dash subtract u v dash over v squared. If we take a look at f, we can state that u is equal to 2x subtract 3 and v equals x squared plus 4. Therefore, u dash, that's equal to 2, and v dash, that's equal to 2x. So let's use the quotient rule. So, we have v, which is x squared plus 4, multiplied by u dash, which is 2, subtract u, which is 2x subtract 3, multiplied by v dash, which is 2x, and we divide this by v squared, so we divide by x squared plus 4 squared. So, x squared multiplied by 2, that's 2x squared. 4 times by 2, that's 8. Then we have negative 2x multiplied by 2x, that's negative 4x squared. Then we have negative 3 multiplied by 2x, that's positive 6x. And we divide this by x squared plus 4 squared. So if we simplify, 2x squared subtract 4x squared, that's negative 2x squared. Then we have the plus 6x, and then we have the plus 8. And we divide this by x squared plus 4 all squared. So therefore f dash of x is equal to negative 2x squared plus 6x plus 8 over x squared plus 4 squared. Part B, hence using algebra, find the values of x for which f is decreasing. You must show each step in your working. So, for part B, if f is decreasing, that means f dash of x is less than 0. So we have f dash of x, that's negative 2x squared plus 6x plus 8 over x squared plus 4 squared. This must be less than 0. And if we simplify, you will find negative 2x squared plus 6x plus 8 being less than 0. Let's find the critical values. To find the critical values, we set the left-hand side equal to 0. And now let's solve this quadratic. If we go to the equation submenu, we have a polynomial of degree 2. We have negative 2x squared plus 6x plus 8, meaning we have a solution of 4 and negative 1. So we have x equals negative 1, x equals 4. Sketching this function, well, we have the x-axis, we have a negative quadratic, we have a solution here at x equals negative 1, a solution here at x equals 4. Now where the graph is less than 0, that's over here, which corresponds to x being less than negative 1. Or we have the values shown here, which correspond to x being greater than 4. Question number 6. Figure 1 shows a sketch of the graph with equation y equals 3 multiplied by the mod of x subtract 2 plus 5. The vertex of the graph is at the point P shown in figure 1. We see the vertex here. Part A, find the coordinates of P. To find the coordinates of P, which is the vertex, that would be similar to finding the turning point of a quadratic. Hence, for part A, the x-coordinate of P will be positive 2, and the y-coordinate will simply be 5. Hence, the vertex has coordinates 2, 5. And we can show that on the diagram here. Part B. Solve the equation 16 subtract 4x equals 3 times the mod of x subtract 2 plus 5. So, we have the equation shown here. If we go to the graphing submenu and graph 16 subtract 4x, and if we also graph 3 multiplied by the modulus of x subtract 2 plus 5, we see the result shown here. And clearly what we see is we have one solution. Let's zoom in to this area. We have clearly one solution. How do we know whether the 3 times x minus 2 plus 5 gives us this solution, or negative 3 times x subtract 2 plus 5 gives us this solution? Well, the way to think about this is to draw both of those graphs. So let's draw the graph of y equals 3 multiplied by x subtract 2 plus 5, and let's also draw the graph of y equals negative 3 multiplied by x subtract 2 plus 5. So let's draw all of these. Well, clearly the pink line intersects the modulus graph here and gives us a negative y value, whereas the green line gave us this original intersection point. If we hide this graph, that becomes clearer. The red graph is the graph of 3 multiplied by the mod of x subtract 2 plus 5. And if I had negative 3 times x subtract 2 plus 5, that has an intersection point here. So if we deselect this, and then select this, here is the intersection point we're after. Which means the only solution we have occurs when 16 subtract 4x equals 3 multiplied by x subtract 2 plus 5. Let's solve this. Well, simplifying this, you will find 7x to equal 17, which means x is equal to 17 over 7. This is our only solution. A line L has equation y equals kx plus 4, where k is a constant. Given that L intersects y equals 3 times the mod of x subtract 2 plus 5 at 2 distinct points, part C, find the range of values of k. Now here we have the coordinates 0, 4, which correspond to the y-intercept of the graph of y equals kx plus 4. Now, if I draw a line parallel to this line segment here, such as the one here, we can see we have one point of intersection. So anything with a gradient less than this will give us 2 points of intersection. Now, this blue graph here has equation y equals 3x plus 4 because this bit and this bit are parallel to each other, meaning they have the same gradient. Now, if I draw another graph here, this graph here passes through the point 0, 4, and it also passes through the vertex P. This gives us 1 point of intersection. So anything with a gradient greater than this line will give us 2 points of intersection. Now, this equation here is given by y equals 1/2 x plus 4. The reason we get this 1/2 is because to find the gradient of this line, well, we have 5 take away 4, which is 1, divided by 2 take away 0, which is 2. So 1 divided by 2 is 1/2. So anything with a gradient 1/2 gives us 1 point of intersection, and anything with a gradient of 3 gives us 1 point of intersection. So for us to have 2 points of intersection, we need a gradient in between 1/2 and 3. So we have the above replicated here. We have the blue graph y equals 3x plus 4. We have the red graph y equals 1/2 x plus 4. We have the original graph y equals 3 times the mod of x subtract 2 plus 5. And k equaling 1/2 and k equaling 3 gives us one solution. We have one solution here, one solution here. And therefore something in between those gives us 2 solutions. And therefore k being greater than 1/2 but less than 3 gives us 2 solutions. Question number 7. Figure 2 shows a cylindrical tank of height 1.5 meters. Initially, the tank is full of water. The water starts to leak from a small hole at a point L in the side of the tank. We see that small hole here. While the tank is leaking, the depth h meters of the water in the tank is modelled by the differential equation dH over dt equals negative 0.12 e to the negative 0.2 t, where t hours is the time after the leak starts. Using the model for part A, show that h equals a e to the negative 0.2 t plus b, where a and b are constants to be found. Now, for us to find out what h is, we would have to solve this differential equation, and for us to do that, we would have to separate the variables and then integrate. So, for part A, we have the integral of dh equaling the integral of negative 0.12 e to the negative 0.2 t dt, and therefore, integrating, we end up with h equals 0.6 e to the negative 0.2 t plus c. Now, when t equals 0, h equals 1.5. And if we substitute these into here, we have 1.5 equals 0.6 e to the 0 plus c. Now, e to the 0 is just 1, so to find out c, we need to do 1.5, take away 0.6, which is 0.9. So c equals 0.9, meaning h equals 0.6 e to the negative 0.2t plus 0.9. Part B. Find the time taken for the depth of the water to decrease to 1.2 meters. Give your answer in hours and minutes to the nearest minute. For part B, we need to set this result equal to 1.2. So we have 1.2 equals 0.6 e to the negative 0.2t plus 0.9. If we subtract 0.9 from both sides, we end up with 0.6 e to the 0.2t equaling 0.3. And if we divide both sides by 0.6, we end up with e to the negative 0.2t equaling 0.5. So now we need to solve for t. So t will equal, well here, we would end up with t equaling negative 5 times the natural log of 0.5. So we have negative 5 times the natural log of 0.5. We end up with 3.46 etc. hours. And to find out what this is in hours and minutes, well, if I take away 3 from this and then times by 60, we have 3 hours and 27.944 etc. minutes. In other words, we have 3 hours, 28 minutes to the nearest minute. In the long term, the water level in the tank falls to the same height as the hole. Part C, find according to the model the height of the hole from the bottom of the tank. Now for part C, what we need to think about is what happens as t tends towards infinity. Well, as t tends towards infinity, 0.6 e to the negative 0.2t will tend towards 0, meaning h will tend towards 0.9. So, as t tends towards infinity, h tends towards 0.9, meaning the height in the long term is 0.9 meters. Question number 8. The functions f and g are defined by f of x equals 4 subtract 3x squared, where x is a real number. G of x equals 5 over 2x subtract 9, where x is a real number and x does not equal 9 over 2. Part A, find f of g of 2. To do this question, we can find out what g of 2 is and then substitute that result into f. So, for part A, g of 2, that will equal 5 over 2 multiplied by 2 subtract 9. And therefore, we have 5 over minus 5, which is negative 1. So now, to find f of g of 2, that is the same as finding f of negative 1. So, we have 4 subtract 3 multiplied by negative 1 squared, which is equal to 1. Part B, find the inverse of g. Well, our first step would be to replace the g of x with y. So, for part B, we have y equals 5 over 2x subtract 9. Now what our goal is to rearrange for x. So if I multiply through by 2x subtract 9, we have y multiplied by 2x subtract 9 equals 5. And if I expand and then gather everything over on one side that contains an x and everything that doesn't contain an x on the other side, we would have 2xy equals 9y plus 5. So, if I now divide through by 2y, we can see then x is equal to 9y plus 5 over 2y. Now, if I swap x and y and replace y with the inverse of g, we can therefore conclude that the inverse of g is equal to 5 plus 9x over 2x. And here, x cannot equal 0, otherwise we'd be dividing through by 0, but x can equal any real number. Part C, for the first part, find g of f of x, giving your answer as a simplified fraction. For part C, for the first part, to find g of f of x, we need to replace the x in g with the function f, meaning we have 5 over 2 multiplied by 4 subtract 3x squared subtract 9. And if I simplify, well, on the top we have 5 and on the bottom 2 times by 4 subtract 9, that's negative 1, and then we've got 2 times negative 3x squared, that's negative 6x squared. So g of f of x is equal to 5 over negative 1 subtract 6x squared. For the second part of part C, deduce the range of g of f of x. Now, what we'll do over here is we'll play around with different values of x. So if I have 5 over negative 1 subtract 6x squared, let's start off with x equaling 1. So we have 5 over negative 1 subtract 6 multiplied by 1 squared. What do we end up with? Well, we would end up with negative 0.7, etc. Let's see what would happen if I have, say, something much larger, such as 100. Well, in this case, we'd get something even smaller. Now, what would happen if I have, say, negative 100? Well, we'd get this very small value. So let's try to make the values of x smaller. What would happen then? Suppose instead of having 100, let's have 0.1. Well, we end up with negative 4.71, etc. What about negative 0.1? Well, we'd end up with negative 4.7, etc. Now let's change this a little, and let's think about what we'd have if we have, say, 0.0001. Or let's change that even further to an even more smaller value of x. Well, what you can see is would be approaching a value of negative 5, meaning the minimum value of g of f of x is negative 5. Now let's rewrite this function g of f of x, and what we'll do is we'll divide both the numerator and the denominator by x squared, and in doing so we have g of f of x equals 5 over x squared over negative 1 over x squared subtract 6. And let's see what happens as x tends towards infinity. Well, as x tends towards infinity, g of f of x tends towards 0, meaning that the range is negative 5 is greater than g of f of x, but is less than 0. The function h is defined by h of x equals 2x squared subtract 6x plus k, where x is a real number and k is a constant. Part D, find the range of values of k for which the equation f of x equals h of x has no real solutions. So, for part D, if we have f of x equaling h of x, we have 4 subtract 3x squared equaling 2x squared subtract 6x plus k. And if I rearrange this, we end up with the quadratic equation 5x squared subtract 6x plus k subtract 4 equaling 0. Now if we have no real solutions, that means the discriminant b squared subtract 4ac is less than 0. So we have negative 6 squared subtract 4 times 5 times k subtract 4 being less than 0. So negative 6 squared, that's 36. Then we have negative 4 times 5 times k, that's negative 20. Then we have negative 4 times 5 times negative 4, that's positive 80. So 36 subtract 20k plus 80 is less than 0. And if I rearrange, we have 116 is less than 20k, meaning k is greater than 5.8. Question number 9. The first three terms of a geometric sequence are 3 to the power of 4k subtract 5, 9 to the power of 7 subtract 2k, 3 to the power of 2 lots of k subtract 1, where k is a constant. Part A, using algebra and making your reasoning clear, prove that k equals 5 over 2. Well, to find the common ratio r, we have to divide successive terms by each other. So we have the second term, 9 to the power of 7 subtract 2k, divided by the first term, 3 to the power of 4k subtract 5, equaling the third term, 3 to the power of 2 lots of k subtract 1, over the second term, 9 to the power of 7 subtract 2k. Now, this 9 we can rewrite as 3 squared. So we have 3 squared, and the 3 squared is raised to the power of 7 subtract 2k. And we divide this by 3 to the power of 4k subtract 5. And this is equal to 3 to the power of 2 multiplied by k subtract 1. And similar to before, we divide this by 3 squared, and then 3 squared is raised to the power of 7 subtract 2k. Now when we have the same base and we are dividing, we subtract the powers. So we have 3 to the power of 2 lots of 7 subtract 2k subtract 4k subtract 5, equaling 3 to the power of 2 lots of k subtract 1 subtract 2 lots of 7 subtract 2k. So now, because we have the same base, we can compare the powers. In other words, we have 2 lots of 7 subtract 2k subtract 4k subtract 5 equals 2 lots of k subtract 1 subtract 2 lots of 7 subtract 2k. And on the left hand side, if we simplify this, we have 19 subtract 8k, and on the right hand side, if we simplify, we have 6k subtract 16. So we have 19 subtract 8k equals 6k subtract 16, meaning 14k is equal to 35. So k is equal to 5 over 2, or equivalently as a decimal, k is equal to 2.5. Part B, hence find the sum to infinity of the geometric sequence. For a geometric series, the sum to infinity is given by a over 1 subtract r, where the mod of r is less than 1. So we need the first term, and we also need r. Now the first term is given by 3 to the power of 4k subtract 5, and we know what k is, that's 2.5. So we have a equaling 3 to the power of 4 lots of 2.5 subtract 5. And working this out, we have 3 to the power of 4 lots of 2.5 subtract 5, which is 243. We now need to find out what r is. And remember, r is equal to 9 to the power of 7 subtract 2k over 3 to the power of 4k subtract 5. So r equals 9 to the power of 7 subtract 2 lots of 2.5 over 3 to the power of 4 multiplied by 2.5 subtract 5. So let's work this out. We have 9 to the power of 7 subtract 2 lots of 2.5 over 3 to the power of 4 lots of 2.5 subtract 5, which is equal to 1/3. Which means the sum to infinity is given by 243 over 1 subtract 1/3. So I have 243 over 1 subtract 1/3, which is 729 over 2. Question number 10. Figure 3 shows a sketch of part of the curve with equation y equals 8x subtract x to the 5 over 2, where x is greater than or equal to 0. The curve crosses the x-axis at the point A. Part A, verify that the x-coordinate of A is 4. So what we need to do in this question is verify that the x-coordinate of A is 4. So, replacing x with 4, the y-coordinate of A is equal to 8 multiplied by 4, subtract 4 to the power of 5 over 2. So let's work this out. We have 8 multiplied by 4, subtract 4 to the power of 5 over 2, which is 0. So because ya is equal to 0, we can therefore conclude the coordinates of A is 4, 0. Let's add this to figure 3. So here we have the coordinates of A, 4, 0. The line L1 is a tangent to the curve at A. Part B, use calculus to show that an equation of L1 is 12x plus y equals 48. What you can see is L1 is a tangent to the curve at the point A. We know what y is, that's 8x subtract x to the 5 over 2. Now, for us to find the equation of the tangent, we first of all need to find the gradient function, and for that we need to differentiate with respect to x. So first of all, for part B, dy over dx, that's equal to 8 subtract 5x to the 3 over 2 over 2. Now, when x equals 4, dy over dx, that's equal to 8 subtract 5 multiplied by 4 to the 3 over 2 over 2. So let's work this out. We have 8 subtract 5 times by 4 to the power of 3 over 2 over 2, which is negative 12. So dy over dx is equal to negative 12 when x equals 4. Now we know the coordinates of A are 4, 0, so we can find the equation of the tangent. So we have y subtract 0 equals negative 12 multiplied by x subtract 4. And if I simplify, we end up with 12x plus y equals 48. The line L2 has equation y equals 8x. The region R, shown shaded in figure 3, is bounded by the curve, the line L1 and the line L2. Part C, use algebraic integration to find the exact area of R. Well, to find the area of R, we've got the area of this triangle, and what we need to do is subtract the area under the curve. That gives us the area of R. And for us to find the area of the triangle, we need to begin by finding the points where L1 and L2 intersect. Now, we know that y equals 8x, and we know that 12x plus y equals 48. So for us to find out where L1 and L2 intersect, I need to replace the y with 8x. So, I've got 12x plus 8x equals 48. So 20x equals 48, meaning x equals 2.4. And from this I can find out the corresponding y coordinate. So I've got y equals 8 times 2.4, which is 19.2, meaning the point at which L1 and L2 intersect is given by 2.4, 19.2. And that's shown here. We can now find the area of the triangle. To find the area of the triangle, we have the base, which is 4, the height, which is 19.2. So we have the area of the triangle equaling a half times 4 times 19.2. And if we work this out, we end up with 192 over 5. To find the area under the curve, we need to integrate the curve between 0 and 4. So we have the area under the curve given by the integral of 8x subtract x to the 5 over 2 with respect to x between 0 and 4. Now if I integrate 8x, I end up with 4x squared, and if I integrate negative x to the 5 over 2, I end up with negative 2x to the 7 over 2 over 7, and I need to evaluate this between 0 and 4. So let's work this out. I have 4 multiplied by 4 squared, subtract 2 multiplied by 4 to the 7 over 2 over 7, and I get 192 over 7. For the lower limit, I'll just get 0. So I end up with 192 over 7. So the area of R is equal to 192 over 5, take away 192 over 7. So I've got 192 over 5, take away 192 over 7, which is equal to 384 over 35. Question number 11. Figure 4 shows the design of a badge. The shape ABCOA is a semicircle with center O and diameter 10 cm. OB is the arc of a circle with center A and radius 5 cm. The region R, shown shaded in figure 4, is bounded by the arc OB, the arc BC, and the line OC. Find the exact area of R. Give your answer in the form a root 3 plus b pi centimeters squared, where a and b are rational numbers. Now, we know that OB is the arc of a circle with center A and radius 5 centimeters, and if AC is a diameter of 10 centimeters, that means AO is also 5 centimeters, meaning we can form an equilateral triangle AOB, such as the one we see in red here. And because we have an equilateral triangle, that means the angle BOA is pi over 3 radians, and that is the same as BAO, and that is also the same as ABO. In other words, we've got 60 degrees for each of those angles. And we'd also have the area of these segments shown here. That's in between this bit and the triangle. Now, the first thing we can do is find the area of the triangle. The area of the triangle is given by a half times 5 squared times by the sine of pi over 3. In other words, a half AB sine C. So let's work this out. We have a half times 5 squared times the sine of pi over 3. So the area of the triangle is 25 root 3 over 4. We can now find the area of each of these segments. So the way to think about this is we've got the area sector, say ABO, so that is the sector, and then what we can do is take away the area of this triangle to find out this segment here, the segment BO. So the area of each segment, that's given by a half times 5 squared times pi over 3, and then we subtract from this 25 root 3 over 4, which is the area of the triangle. So a half times 25 times pi over 3, that's 25 pi over 6, and then we subtract from this 25 root 3 over 4. We also have the area of the entire semicircle, which we can work out. The area of the semicircle is given by pi times 5 squared over 2, which simplifies to 25 pi over 2. So now we can find the shaded area. So to find the shaded area, we can do the area of the semicircle, take away essentially this entire unshaded bit, and that comprises of the triangle and each of these segments. So the shaded area, that's 25 pi over 2, take away. Now here we've got to take away the area of the triangle, which is 25 root 3 over 4, and then we take away the two segments, so we have two lots of the areas of those segments, 25 pi over 6, subtract 25 root 3 over 4. So let's work this out. Well, we have over here negative 25 over 4, subtract 2 multiplied by negative 25 over 4, and we multiply this by root 3. So we have 25 root 3 over 4, and then we have 25 over 2, subtract negative 2 times 25 over 6 pi. So we add on 125 pi over 6. So the shaded area is equal to question number 12. Part A. Express 140 cos theta subtract 480 sin theta in the form k cos of theta plus alpha, where k is greater than 0 and alpha is in between 0 and 90 degrees. State the value of k and give the value of alpha in degrees to 2 decimal places. Now, k cos of theta plus alpha, that's in the form k cos of a plus b. Meaning, we'd have to use the identity highlighted here. Cos of a plus b is equal to cos a cos b subtract sin a sin b. So, for part A, 140 cos theta subtract 480 sin theta will be equivalent to k cos theta cos alpha subtract k sin theta sin alpha. If I compared the cos thetas, on the left hand side we have 140 and on the right hand side we have k cos alpha. And if I compared the sin thetas, noticing on the left hand side and the right hand side the negatives simplify to a positive, we have 480 equals k sin alpha. And therefore, if I divide these equations by each other, k sin alpha divided by k cos alpha, that's sin alpha over cos alpha, and then we have 480 over 140. So sin alpha over cos alpha equals 480 over 140. Now sin alpha over cos alpha, that's tan alpha. So tan alpha equals 480 over 140. If we work out what alpha is, that's the inverse tangent of 480 over 140. So alpha to 2 decimal places is 73.74. We can find the value of k using Pythagoras. K is equal to 140 squared plus negative 480 squared, all square rooted. So we have the square root of 140 squared plus negative 480 squared. It turns out k is 500. And knowing alpha and knowing k, we can therefore conclude 140 cos theta subtract 480 sin theta is equivalent to 500 cos of theta plus 73.74. A scientist studies the number of rabbits and the number of foxes in a wood for 1 year. The number of rabbits, r, is modelled by the equation r equals a plus 140 cos of 30t degrees subtract 480 sine of 30t degrees, where t months is the time after the start of the year and a is a constant. Given that during the year the maximum number of rabbits in the wood is 1,500, for the first part of part B, find a complete equation for this model. For the first part of part B, r will equal, well, if the maximum number is 1,500, that means we have 1,000 plus 500 cos of 30t plus 73.74. So adding together the 1000 and the 500 from the equation we found in part A gives us this 1500, and this ensures it's in the form given to us in the question. For the second part of part B, hence write down the minimum number of rabbits in the wood during the year according to the model. Well, quite simply, the minimum value of r is 500. The actual number of rabbits in the wood is at its minimum value in the middle of April. Part C, use this information to comment on the model for the number of rabbits. Well, if t months is the time after the start of the year, and we are considering the value in the middle of April, that means we have to consider t equaling 3.5. So, for part C, with t equaling 3.5, r will equal 1000 plus 500 cos of 30 times 3.5 plus 73.74. So we have 1000 plus 500 times by the cosine of 30 times 3.5 plus 73.74. It turns out we get 500.12, and because this is almost 500, we can therefore conclude the model is suitable. The number of foxes F in the wood during the same year is modelled by the equation F equals 100 plus 70 sine of 30t plus 70 degrees. The number of foxes is at its minimum value after t months. Part D. Find, according to the models, the number of rabbits in the wood at time t months. Because we are looking at the number of rabbits, we'd have to use this equation here. That is, r equals 1000 plus 500 cos of 30t plus 73.74. Let us find the value of t which gives us a minimum. Well, in this case, we'd have sine of 30t plus 70 equaling -1. And therefore, if we take the inverse sine of both sides, we would have 30t plus 70 equals 270, meaning t equals 20 over 3. This will give us the minimum. So, r is equal to 1000 plus 500 cos of 30 multiplied by 20 over 3 plus 73.74. So let's work this out. 1000 plus 500 times by the cosine of 30 times 20 over 3 plus 73.74. That gets us 1032.6, etc., meaning we have 1032 rabbits. Question number 13. Part A. Given that A is a positive constant, use a substitution x equals a sine squared theta to show that the integral of x to the 1/2 multiplied by the square root of a subtract x with respect to x with the limits 0 to a is equal to 1/2 a squared multiplied by the integral of sine squared 2 theta with respect to theta with the limits 0 to pi over 2. So, for part A, we begin with x equals a sine squared theta. If we find out what dx over d theta is, we can use the chain rule. So here we have 2 multiplied by a, which is 2a, then we multiply by sine theta, and then we multiply by the differential of sine theta, which is cos theta. So dx over d theta is equal to 2a sine theta cos theta. And if I rearrange for dx, dx is equal to 2a sine theta cos theta d theta. Let's think about our original limits x equals 0 and x equals a. Well, when x equals 0, that means we have 0 equals a sine squared theta, meaning theta is 0. And when x equals a, we would have a equals a sine squared theta. So, the a's simplify on both sides to 1, so we have 1 equals sine squared theta, meaning sine theta is equal to 1, meaning theta is equal to pi over 2. So we have our original integral of x to the 1/2 multiplied by the square root of a subtract x with respect to x with limits 0 to a. So, using the information we have worked out, this is equal to, well, we've got the integral from 0 to pi over 2, and then we know that x is equal to a sine squared theta, so we have a sine squared theta to the 1/2 multiplied by the square root of a subtract a sine squared theta, because x is equal to a sine squared theta. And then we already know what dx is, that's 2a sine theta cos theta d theta. So we've got the integral from 0 to pi over 2. Now here, a to the 1/2, that's the square root of a, and then we multiply by sine theta, because sine squared theta to the 1/2 is just sine theta. And then I can factorize out the square root of a here, leaving me with the square root of 1 subtract sine squared theta, and then I have 2a sine theta cos theta d theta. So I've got the integral from 0 to pi over 2, and then I have square root a times square root a, that's just a, and then I multiply by sine theta, and I multiply this by the square root of 1 subtract sine squared theta, which is the same as square rooting cos squared theta, and then I multiply by 2a sine theta cos theta, and all of this is integrated with respect to theta. So I have 2 multiplied by a, so that's 2a squared, and then I've got the integral from 0 to pi over 2, and then here I've got sine theta times sine theta, that's sine squared theta, then I've got the square root of cos squared theta, which is just cos theta, multiplied by another cos theta, so that's cos squared theta, and don't forget your d theta. And what I can do is group together the sine squared theta and the cos squared theta as sine theta cos theta all squared. And if we use the identity for sine 2 theta equaling 2 sine theta cos theta, but recognizing that we have a sine theta cos theta, we can replace the sine theta cos theta with 1/2 sine of 2 theta all squared d theta. And so 1/2 squared is a quarter, and multiplying that by 2a squared, we get a half a squared. Then we've got the integral from 0 to pi over 2 of sine 2 theta squared d theta, which is what we wanted to show. Part B, hence use algebraic integration to show that the integral of x to the 1/2 multiplied by the square root of a subtract x with respect to x from 0 to a is equal to k pi a squared, where k is a constant to be found. So, continuing on from part A, well, we have this 1/2 a squared times the integral from 0 to pi over 2 of sine squared 2 theta d theta, and this sine squared of 2 theta we can rewrite as 1/2 multiplied by 1 subtract cos of 4 theta d theta. So we have the 1/2 times by this 1/2, which gives us a quarter, and then we have this a squared, and we multiply by the result of integrating 1 subtract cos 4 theta with respect to theta. So if I integrate 1, I end up with theta, and if I integrate negative cos 4 theta, I end up with negative a quarter sine 4 theta. So I need to evaluate this in between 0 and pi over 2. So I have this 1/4 a squared, and if I substitute in for my upper limit, I've got pi over 2 subtract a quarter of sine times by 4 times pi over 2, and for my lower limit I'd have 0 subtract the sine of 0. And therefore, if I work out what this is, well, Here we've got the sign of 2 pi, which is 0. Here we've also got 0. So I've got a quarter a squared times pi over 2, which is 1/8 pi a squared, meaning k is equal to 1/8. Question number 14. A balloon is being inflated. In a simple model, the balloon is modelled as a sphere. The rate of increase of the radius of the balloon is inversely proportional to the square root of the radius of the balloon. At time t seconds, the radius of the balloon is r centimeters. Part A. Write down a differential equation to model this situation. For part A, because the balloon is being inflated, the rate of change of the radius with respect to time will be positive, and we know that the rate of increase of the radius of the balloon is inversely proportional to the square root of the radius of the balloon. So we have dr over dt equals k over the square root of r. At the instant when t equals 10, the radius is 16 centimeters. The radius is increasing at a rate of 0.9 centimeters per second. Part B. Solve the differential equation to show that r to the 3 over 2 equals 5.4t plus 10. So, we know that dr over dt equals 0.9. So we have 0.9 equals k over the square root of 16. And if I solve for k, 0.9 multiplied by 4 is 3.6. So k is 3.6, meaning dr over dt equals 3.6 over the square root of r. If I now separate the variables and then integrate, we have the integral of the square root of r with respect to r equals the integral of 3.6 with respect to t. Integrating r to the 1/2, we end up with 2r to the 3 over 2 over 3, and integrating 3.6 with respect to t, we end up with 3.6t, and we add on a constant of integration plus c. We know that when t equals 10, r equals 16, so we have 2 multiplied by 16 to the 3 over 2 over 3 equals 3.6 multiplied by 10 plus c. Let's solve for c. We have 2 multiplied by 16 to the power of 3 over 2 over 3. Subtract 36. Therefore, c equals 20 over 3. Knowing that c equals 20 over 3, we can therefore conclude 2r to the 3 over 2 over 3 equals 3.6t plus 20 over 3. And if I multiply both sides by 3 and then divide by 2, we end up with r to the 3 over 2 equals 5.4t plus 10. Part C. Hence find the radius of the balloon when t equals 20. Give your answer to the nearest millimeter. When t equals 20, we have r to the 3 over 2 equals 5.4 multiplied by 20 plus 10. So now let's solve for r. If I do 5.4 multiplied by 20 plus 10, that's equal to 118. So r to the 3 over 2 equals 118, meaning r will equal 118 to the power of 2/3. which is 24.057, etc. So to the nearest millimetre, r is 24.1 centimetres. Part D. Suggest a limitation of the model. For Part D, a limitation is the model will not hold infinitely as the balloon may burst. And that makes sense. The more you inflate a balloon, the bigger it gets, but the danger is the balloon may burst. Question 15. For the first part, show that k squared subtract 4k plus 5 is positive for all real values of k. So for the first part, we've got k squared subtract 4k plus 5, and what we can do is complete the square. So we have k subtract 2 all squared, then we subtract the square of 2, so we subtract 4, and then we add on the 5. And simplifying, we have k subtract 2 all squared plus 1. Now, k subtract 2 all squared is greater than or equal to 0, and of course 1 is greater than 0, meaning k subtract 2 all squared plus 1 is greater than 0, and because the left hand side is equivalent to k squared subtract 4k plus 5, we can therefore conclude k squared subtract 4k plus 5 is greater than 0 for all real values of k. For the second part, a student was asked to prove by contradiction that there are no positive integers x and y such that 3x plus 2y multiplied by 2x subtract 5y equals 28. The start of the student's proof is shown below. So, assume that positive integers x and y exist such that 3x plus 2y multiplied by 2x subtract 5y equals 28. And then what they've done is they've set the 3x plus 2y equal to 14 and the 2x subtract 5y equal to 2. Notice the 14 and the 2 are factors of 28. And in solving the simultaneous equation, they find that x equals 74 over 19 and y equals 22 over 19, and these are not integers, which is a contradiction to the statement here that x and y are positive integers. So we have to show the calculations and statements needed to complete the proof. First of all, let's think about the factors of 28. We've got 2 and 14, we've got 1 and 28, and 4 and 7. One of the simultaneous equations has already been considered. That is 3x plus 2y equals 14, 2x subtract 5y equals 2. So let's swap those round. So with our first case, we have 3x plus 2y equals 2 and 2x subtract 5y equals 14. Now let's solve this. If we go to the equation sub-menu on our calculator, we have a simultaneous equation with two unknowns. So we have 3x plus 2y equals 2, 2x subtract 5y equals 14. And if I solve, I have x equals 2, y equals negative 2. And we reject these because y equals negative 2 is not positive. For the next one, we have 3x plus 2y equals 28, 2x subtract 5y equals 1. So we have 3x plus 2y equals 28, 2x subtract 5y equals 1. You will find x to equal 142 over 19, and you will find y to equal 53 over 19. These are not integers, so we reject these. Next, we have 3x plus 2y equals 1, 2x subtract 5y equals 28. So, we have 3x plus 2y equals 1, 2x subtract 5y equals 28. And in this case, we find x to equal 61 over 19, y to equal negative 82 over 19. These are not positive integers, so we reject these. Next we have 3x plus 2y equals 7 and 2x subtract 5y equals 4. So we have 3x plus 2y equals 7, 2x subtract 5y equals 4, and solving you will find x to equal 43 over 19 and y to equal 2 over 19. These are not integers, so we reject. Next we have 3x plus 2y equals 4, 2x subtract 5y equals 7. So 3x plus 2y equals 4, 2x subtract 5y equals 7. And solving, you will find x to equal 34 over 19, and you will find y to equal negative 13 over 19. These are not positive integers, so we reject. Now, you will find in our calculations we have positive 14, positive 2. We have 2 and 14. Then we have 28 and 1 and 1 and 28. And then we had 7 and 4 and 4 and 7. We could have chosen the negative pairs of those as well. So for example, having 3x plus 2y equals negative 7 and 2x subtract 5y equals negative 4, etc. We still would have ended up with similar results to each of these. So essentially, the negative pairs also result in values of x and y which are not integers. Therefore, the above is a contradiction to the assumption that there are positive integers x and y such that 3x plus 2y multiplied by 2x subtract 5y equals 28. Hence, there are no positive integers x and y such that 3x plus 2y multiplied by 2x subtract 5y equals 28.